bicycles.
I want to ride my bicycle. I want to ride my
Alright, so the physics of bicycle gear ratios. What is a gear? A gear is typically a round, flat piece of wood or metal with teeth around it, an even amount of teeth. Gears, they typically only work in pairs, as if you have one gear with a chain going around it, it's not really going to do you much good. The only exception I could think of was a unicycle, but it still doesn't really have an effect, as all your power is being directly transferred into the chain, so it doesn't really have a purpose. Okay, so there's a couple different types of gear sets too. There's bevel gears, which are basically at a 90-degree angle, and one spins the other like this. I'm using saw blades, yes, but you get the idea. Goes like that. Also worm gears, which you have a long spindle like this with threads on it. It's attached to the gear, and the gear will spin, and it will spin the rod as so. And then there's also spur gears, which are what on bicycles. They basically just interlock like this and turn as you would think a normal gear would. On the bike we'll be using today, and of typical most bikes, there are 3 sprockets in the front, on the front drive, chain rings, and a cassette in the back, usually consisting of 7 gears and sprockets. All teeth on gears have to be the same size on the mechanism. So for this, a bicycle, they all have to be the same size so that they can mesh together and actually work, because they obviously wouldn't if all the teeth were random sized. Gear ratios are measured by the number of actual teeth on the sprocket. So say if you have a 36 in the front and an 18 in the back, that would be a 36 to 18, and then you divide it down to the smallest number that you can, so it'd be a 2-to-1 ratio, meaning that the smaller gear turns twice each time the larger gear turns once. There are 2 types of gear sets, hunting and non-hunting. Alright, I'm going to intervene with a voiceover here, because what I was saying was stupid, but I was trying to say that hunting gear sets are used when you need to line up the gears perfectly, and they need to hit the same spot every time, like in a car, because if you don't have that, then stuff will start breaking. And then there's non-hunting gear sets, where the teeth just go with whatever teeth they want to. It doesn't have to be lined up perfectly, and that's why they're used in bikes, because this is the only drivetrain on the bike. You don't have to worry about camshafts and crankshafts and all that junk. It's going to work fine. Their only job is to take the input force, which is your legs, you're putting the force on the pedals and the cranks, and to multiply it in the output force to either speed something up or to make it easier to turn. This is also how you get in-between gear ratios, like 3.25 to 1 or 4.85 to 1, because it's not lining up with the same every time. That wouldn't make any sense. You can't have it like flopping gear ratios every time you pedal. Non-hunting is also used to get the in-between gear ratios, like 3.25 to 1 or 4.85 to 1. When it doesn't have to be a precise like 2-to-1 ratio. You can have some funky stuff going on, like on a bicycle. Okay, so now we'll talk about the types of actual drivetrain. First you have derailleurs. It's a little arm hooked to the rear cassette of your bike in the hub, and it basically acts like an arm too, pushing the chain up and down the different gears so that you can change your ratio, and we'll give you a demonstration. Going to the smaller gears. Can you see the derailleur moving? Mm-hmm. Now go back up. Look at that. Okay, so here's a demonstration of how the derailleur works. I'm gonna turn the wheel nice and slow. And as we go into the smaller gears, the tire, if it shifts, will get faster and faster while keeping the pedal speed at the same rate. Look at that, thing's cruising now. So now we're going to do the same demonstration, but using just the front gears, which have a much more drastic change in teeth. So you should see the tire spin much faster. So we're going to start out nice slow speed. First gear changing into second. It's going faster, and then changing into third. Now without actually applying more force through your legs into the cranks and pedals, just by changing the ratio of the gears and chain that's already there, you can go faster.
Okay.
In this demonstration, I am riding up a hill in a gear ratio of 1.4, so that's a 1 in the front sprocket and a 4 in the back on this bike. And it shows how easy it is to ride up a hill. You get less distance, but in turn it's easier to turn the pedals. But if you stay in that 1.4 ratio as you go downhill, you can see my legs are flying and it's not very effective because you are going distance over speed. But in this one I changed the ratio to 2.4. So it's going to be much harder to pedal up this hill because it's trying to get more distance, so you need more power out of it. So it's not very practical. But as you see, when I start coming back down the hill, it's much more efficient because my legs aren't going 100 miles an hour and I can actually keep up with the amount of distance that I'm riding over. Oh yeah. So derailleurs of a mid-ranged product, which would be one that a serious amateur would use, comes standard on bikes, $800 and up. The efficiency percentage of power that is transferred directly from your legs to the actual wheels is 88% to 99%. So depending, the more weight and the harder you're actually pushing, the less power you'll lose in the process, but you're always going to lose some just because you're linking two different sets of gears together. That some power just gets lost in space. So the internal hub gear, which this is a hub, you should probably show them what a hub is. No, we're going to show them a video later. Okay, so internal hub gears work by internal planetary gearing, which is just a fancy term for when the hub outer turns faster but at an adjustable rate, so you can change it just like this, to the actual gears that are inside the hub itself. And I never even heard of this type of gearing, so I obviously don't have anything to show you, but I'll show you a video of hopefully the internal components of how it works. This is that video that shows you the inner workings of an internal hub gear, and I would explain how it works, but I've watched this video multiple times and I've read articles and I still don't really get it enough to explain it, and I don't want to just talk and like feed you guys false information. So yeah, I don't know. So for this experiment I was trying to demonstrate how it is easier to push something or make it turn from the outside than it is from the inside. And I was trying to demonstrate how there's a trade-off for like ease of turning for speed, because if you're on the inside it's going to be harder to get it going, but you have to make less steps around the actual unit. Whereas if you're on the outside, you're going to take more steps, but it's easier to push. And yes, I realize this experiment is complete BS. 10 seconds.